here might be better. Yeah, if it.
For me, and
Oh, for
I
all of
want
us. Yeah,
all
all
of
of
us.
us together. Okay, yeah, no, that could work. You just have to block the view. Yep. All right. Yeah. Okay. All right. So yeah. So ChemTube 3D is the website.
ChemTube, right?
Yeah. So and basically you can load up lots of different structures, structures here. I like the solid state materials. There's some quite complex. I do a lot of solid state physics, so that's why I'm down here. But you know, there's also some really nice stuff on bonding, which I quite like. So orbitals are really good, symmetry groups. And they've also got animated molecular orbitals, which are super cool. So you can do a SN2 reaction with the orbitals, and the orbitals are actually done using a localized orbital, so they kind of, it's a bit easier to see the reaction. So yeah, so then you can see this bond breaking and forming, going between this this p orbital of the oxygen attacking the that site, I think. Yes. Okay, so again, it's already in perspective, which is good, and then you go over to red cyan. So depends on the glasses, but if you look and you see it sort of looks like a light blue, it's cyan, and if it's very blue, like this color, then it will be a red blue. But but almost all of them, red cyan is best, yeah. So, but the problem is you cannot do color. So there's no color with red cyan. So if you put the glasses on, you can see in 3D that. So it's quite, I find for orbitals it's quite good because you can see it in 3D. So this is by far the cheapest approach, and I've actually been working a bit with the Raman Institute in India on using this as a low-cost thing, because you can buy these for a few cents, and you can do it in sort of small, communities, and you can kind of send a kit out of these, and it's pretty good. It's not too bad, yeah, for that price. It's a really good price point. So that's the sort of first thing that I've been doing. And then the second thing is using the Google Cardboard. So let me just, I'll just kill that for now. So that's up here. I don't know, maybe not. I want to show you that. It's quite cool as well. Good thing about long arms is you can
use the top shelf.
That's the top shelf. Actually, I forgot my phone. Do either of you have a phone, a cell phone?
Oh, cell phone?
Yeah.
Okay.
And may be able to download an app. Sorry. I should have, I forgot entirely about my cell phone. Very annoying. Yeah, the app is called MELVR, the MELVR.
Now it's Apple.
I think it is for both, but maybe it's not. Yeah, so it's MELVR.
This one?
Yep. Yeah, is it free? It should be free. I hope it's free. Yeah. So this is one of the most, it's like so easy to use, and you literally need, so you can buy one of these Google Cardboard things. I bought this from the Science Museum in the UK. Yep, that's the one, yeah. But I've also got here, recently I bought some of these here. Yeah. Which I think is even easier. Yeah, like that. And yeah, and basically you put it onto your cell phone, and you look at your
I see your cell phone goes
basically right there.
Yeah.
And you then, as you move around, it basically it tracks the position of your head. So the one that I recommend, there'll be something that says, oh yeah, has it done the 2 thing? Oh, there we go. Yes, so what we do is we have to go up to settings and we have to go to switch to VR mode.
Mm-hmm.
Yep. And then I'll just be careful with it because I don't want to scratch it. Like so. Yep. And now, as you move around, you'll be able to, and you just touch the screen as the setting. And I'll give you one too, Laura. I don't know if it's better or not with the glasses, but
I can't read with my glasses on.
alright.
So they could
Oh, that's probably not going to help you at all. So we're going to switch to the VR mode there. Yep, and then we put that on like so. Yep, and then if you put that on, like you kind of, yeah, and then you can walk around, move around a bit. And what you want to do is go over to the one that is like the atoms. So it'll say, yeah, so you have to look to the, have you've done lithium. Let me do one.
No.
I want to show you the one that's good. Oh yes, so let's just,
got some molecules in the background there. Looks like a sugar.
yes. Yeah, this one's not as, oh that's right. You look down and then you go back to the one. I just want to show you the one that's kind of, so the atoms and solids is my favourite.
Okay.
Organic area.
Do you want to go over to the pencil lead there? You might be able to see if you zoom around. There should be like a set of 6 tiles, and then can you see the set of tiles going around?
Oh, I can see. I've done the full. This one you can't read it.
Oh, let me have a look. I'll get it sort of started for you. Oh yeah, sorry. It's I had to exit out of the menu. Sorry. So if you look now, you'll see that there's atoms and atoms.
Oh, yes, yes, yes.
And point towards the pencil, which is to the left of you, I believe.
Left is this one.
Yeah, you can put the point on something.
I can
Go,
see it.
go onto the pencil. See how there's those 6 there? So go and put your sort of cursor, which is that middle dot, over the pencil, and then tap the screen.
I don't see pencils. Oh yes, yes, I do.
Yep.
At the top.
And
Slightly
then,
out of focus. My eyes don't focus.
yes, and then tap.
Just touch the screen.
Yep.
Okay, now I've got the periodic table.
Yeah. Good.
All matter is built of atoms that are constantly moving. In solids, like our diamonds, they vibrate. You can see how each atom is connected to 4 others. Such a strong structure makes a diamond one of the hardest materials. Let's return back to our laboratory. We also have a pencil here. It's 1 billion times cheaper. Interestingly, its lead is made of the same carbon atoms as a diamond. Let's look inside. Ready to dive? We have to zoom in about 1 billion times to see the individual atoms. They are the same carbon atoms as in a diamond, but their arrangement is different. As you can see, they are laid out in layers. These layers are easy to separate from each other since there is no strong bond between them. This makes graphite much softer than a diamond. When you write with your pencil, the marks on the paper are traces of graphite. You can fly inside this graphite crystal and explore it by yourself. Just to remind you, you are now as small as an atom, and what you see around you is the tip of a pencil enlarged 1 billion times. Let's go back to our laboratory. You have seen that both diamond and graphite are built of the same atoms, but they have very different properties because of their atomic structure. Try to recall how small the atoms are. What do you think is bigger, an atom or a bacterium? A bacterium is much, much bigger than an atom. Each bacterium contains billions of atoms. Now, try to think how big an atom is. An atom is about 10 million times smaller than a millimeter. If an atom were the size of an ant, then this ant would be the size of Manhattan.
Yeah.
He's ahead of me, so I'm hearing his
Yeah. So you get the idea. So
Yeah.
that's really where I started to see this as like quite immersive, because particularly when you're inside the atoms and moving around, it's really cool to be able to drive around, you know, and to be able to see, and in particular see in 3D SP3 versus you know, the graphite layers. It's very, very clear. And so I showed this to a student and I said, you know, can you do something like that for me? and so then he came up with a VR game based basically around this. But what I also wanted to do is use like that. Those are just artificial, perfect structures. But in our research, we actually simulate using the computer the structure of graphite and of disordered carbon. So we have some very accurate simulations. So we've got really nice models. So I thought, wouldn't it be great to put new cutting edge, you know, models into that? And it would be great for us as a research tool. So for example, this structure here is a structure of, if you just exit out of the phone, it should stop beeping. There we go. Yeah, so this structure here is a 3D print of a structure which is only kind of a nanometer across. These are the sheets of carbon, like the graphite sheets. And this is the structure of charcoal. So this is the structure of charcoal. And we've got different structures here. This is a porous carbon. You can actually see I put the bonds in there. So this is like much more complicated than graphite that you saw. And so what we wanted to do is put these complex models into the VR. And also this is 32,000 atoms, but we wanted to put 1 million carbon atoms. And it's actually hard to put that into the computer. So we decided to do a simulation where you're inside it and you can only see nearby, so that we don't have to render every atom. So it's like you're sort of, the student calls it molecular caving. You know, or so that is so he did this with, these are the large models that we had. I can put that over here if you want. And so he basically made a program in Unity, yeah, so that he could, and this is an early version of it, where you can move around, and this is you inside of the simulation box, and as you move forward around inside of it, you can actually see that you move out of the side of the box, and then you jump back to the other side of the box, because they're periodic simulations. So that means that this edge here is connected to that edge. And that's very hard to communicate to people, but you can see you could keep going. As you went out here, you go in there, and then you come out. And so it's like a continuous space. So if you go to the left, you then jump to the right. Yeah, that's really hard to communicate, by the way, if you're in a lecture setting. But showing this video, you can see it's continuous across the interfaces. So. That's quite nice, though a little bit.
And so this is carbon with some oxidation?
No, so as in the physics, we only do carbon. So we colour atoms according to their connectivity. So if they're connected to two neighbours, then we colour them red. We actually changed the colour scheme so that there wasn't any, I changed the colour scheme so there wasn't any CPK colours. So this is the new version that we have here that I can demo to you, and it basically uses purple for the sp2 carbon atoms, and then the edge atoms, which are sp2, are yellow, and then if you have a diamond atom with 4 neighbours, you have
what atom?
Let's have a
Yellow
look.
one is.
This is 2 neighbours, and then if I find this one here, this kind of orangey colour, it's got 1, 2, 3, 4 bonds, so that's diamond. And then this is like an unsaturated sp2. That's funny because the physicist.
That's on an edge.
Yeah, that's on an edge. Yeah, so there's nothing bonded there. So this is like a vacancy. So that's the colours at least. What I'll do is I'll set it up here. I'll do it on this chair.
The your students made this kind of model.
Yeah,
Oh, that-
yeah.
right.
So a third year student at university. Yeah.
But in Unity.
Yes,
Oh,
yeah.
right.
So he
That-
inserted each atom, the position XYZ, as a sphere at each point, and then he put a cylinder between each, depending on if they were within a certain cutoff. So it's a bond. There's an algorithm to figure out whether it's bonded or not.
So he had atom positions.
Yep. That's all he had. Yeah. So I just gave
Like
him.
an
I gave him the
assist
atom. Yeah, the atom positions from this. And, I literally gave him an XYZ file, so it didn't even have a first column. It's just the X, Y, and Z positions of every single point, and every single point represents a carbon atom. Yeah.
He didn't download it on the website.
No. Well, this is our sort of. So we actually using computer simulations. We will take a structure, and using a supercomputer, we will use the computer to make the bonds form and break, and to jiggle them with the temperature, and we can actually make them transform into an annealed carbon. So we can use the computer to do the experiment. Yeah, which is an interesting thing. So yeah, so that's what we. So we make these structures, these complex carbon structures, using a very large supercomputer. Yeah. So there is, I think, on carbonpotential.org, we've got some structures that we put on .org. If you go to carbonpotentials.org, and then I think it's still going. Potentials. Oh no. Compare, and then Edict is the one that we like the most, and you can do the 3D visualization, and then if you go view full, it'll put that as a structure on the web, and then if you press download, you get an XYZ file. Yep. So then you can open that in VMD or whatever you want, whatever visualizer you've decided to do. So yeah, so that's it in VMD. And of course VMD does anaglyph too, stereo anaglyph, not very well obviously. Gosh, it's not looking good at all. Why is that? It's almost looking like it's trying to do something else. Stereo.
Is that? It seems like it's vibrating.
Yeah, I think it's trying to do the quad buffet 3D. Anyway, so yeah, we do have these structures available online, but to be honest, when you look at it online, the immediate thing you look at is all these edges, right? It looks like a cube, and you focus on the edges, right? But there's no edges because the simulation connects. So when you look at this, you get the wrong idea. It should really be that inside, yeah, the edges are inside, so there's an edge inside here, not at the edge. So let's start with something easy. The first one I think we'll do is, I should check that it's working. I tried it out in a lab yesterday, I think, so it has been working. It is software designed by a student, but he did some really good work, like all GPU enhanced, and it's he spent a lot of time making it run really, really fast. Okay, so where is it? Carbon Nanoverse is the name of the game, which we've yet to put.
And your students render to APK file, and you
I'm not actually sure how they do it. I should ask. From what I understand, they just load it into the headset. Yeah, so that it's not currently as part of a library or anything. Why is that so unhappy? Weird. Yeah, let me just. Ever since the issue is ever since was taken over by Meta, it's just an absolute nightmare. Yeah, and it wants more batteries. Great. Let me just do some battery resuscitation. Yeah, there we go. Some battery resuscitation.
High tech.
Alright, hopefully that's gonna get me done. I do. There are batteries downstairs if I need to go and grab them.
I have.
Oh, you've got two controls as well.
Yeah.
Let's see if I can get this going. This needs to work. Very. No, I do need the batteries, sorry. I'm gonna. It's completely dead.
You can borrow it?
Yes, am I able to borrow? I just need one. Just need the right side. Sorry about this. Should have checked that. Yeah, thank you. Sorry about that.
Oh, it's okay.
You know how quickly the batteries die.
Yeah.
There we go, and we're working. All right, we're in business.
Then one more.
Oh, it should be right. I don't think I need it. We only need one controller. Create new boundary. Choose all own boundary. Stationary. Issue. Okay. Confirm. Alright. So let me put you into graphite first. Input file. Interestingly, it doesn't. It needs the right hand side. Really? Good. No, I do need the other battery.
Oh,
I'm very sorry.
it's okay.
For some reason needs another battery. I don't know how the student made it, but sorry about this. Thank you very much. Sorry about that.
So you're in AR at the moment.
I was. Now I'm out of AR. I didn't put it in AR. So this is the screw defect. So this is a model of graphite, like real graphite, that you would actually have like in your pencil bed. So the way it works is you push forward like that, and then where you look, you go. So it's almost like you're sort of Superman. So you kind of zoom around. So you can have a sit here if you want. Yep. Do you want to sit down?
Okay.
Yeah, it's got, you know how it works with the skirt. Yeah, you just need, that's just the joystick. That's all you need. You can adjust it if you want.
Oh, I can see.
Oh, you just need one, but you can, yeah, I can move down the wall.
Oh.
Yeah, and then you push this forward. Yeah.
Oh, okay. Where I look, I can go.
Yes, yeah. So you just, the only thing you can do is push forward, and then you use your head to do the steering. We found that to be the less vomit-inducing.
But yeah.
To be honest, it's I get very bad motion sickness, so the student had me to contend with. So that's really helpful.
Pardon, how did you make the students not to vomit?
No, it was just me. So he would do it, play at home, and then he would give me actually what he did is he put the parameters on my hands. So the speed at which you move could be changed by gripping either side. So what I would do is I would move forward and then see if I felt ill, and then I would either speed up the motion or slow it down. And this is the speed that I could deal with for about 5 minutes. Some people are fine; they just keep going, but I'm very sensitive, so I can't do VR games in arcades and things because they're too, vomit-inducing.
Oh.
So, to be honest, we've now made some more. We've got some more ideas about having like barriers around you, and that helps to make you feel like you're safe. And to be honest, this is the worst case scenario. You're floating in midair.
Yeah, well, he has a visit the space station thing that he does with his students, and I used that, and I was I had to take it off because I got to the
Yeah.
point where I couldn't control it well enough.
Yeah.
So I was zooming here, banging into wall, and up here, down there.
Yeah.
And I think if you could control it to move at your
own
pace,
yeah.
you're okay.
Yeah, that's right. So I can show you another structure if you want. Have I shown you this tomorrow?
Sorry?
Have I shown you this?
I don't know if I've seen
Oh,
this one or
all right.
not. I've seen,
Have a sit down.
I've seen
sorry.
something at the advanced science
There you
exhibition.
go. And thumb on
It's
the
just that one.
joystick. Yeah, and then I'll just try to adjust it to
You
your
can
liking.
mirror.
Oh,
Mirror
okay.
here.
I can, but it's a pain.
I will show.
Yes. You can if you.
So this is graphite, yes, I can
Yeah.
recognise graphite.
But you can also see some screw dislocations in there. If you move around a bit, you might see one layer sort of spiraling up and connecting to the next layer above. So those are the defects that we discovered recently in graphite. So they're, well,
Endless.
And the red one's a tetrahedral base.
correct.
Oh yeah, so you've got. Oh.
So it's quite nice, and it's you can change the atom size. You can change the
Oh,
so you can make it look completely different as well. So there's settings that the student put in, so you can change what it looks like. Yeah.
Oh, actually,
but when you playing, I cannot change the
No,
size,
no. There's like easy mode and there's hard mode, and hard mode has a lot of the different things set on the controllers, so you can change how it looks in real time. Yeah.
okay, so the red ones are actually the SP2, but only doubly connected, and the gold ones.
Oh yes,
think
it's
it's
the other way
possible.
around. Yeah,
Yeah.
sorry. Yeah, I think we.
There's not so many gold ones, but the gold one is where you have
Yeah.
the connection going to the top.
Yeah, but you can also see that the entire plane is also snaking around and zooming up to the next layer in a few different
Yes.
places. So it's quite a beautiful structure. Yeah.
It's incredible, and the gaps everywhere. It's
Yeah.
you know, we talk about carbon having all 4 bonds, and then there's lots of here that's missing bonds.
Yeah, and actually graphite has quite a high paramagnetism because of unbonded carbon, so it's quite.
And the
quite-
I was asked by a school teacher a long time ago, the diamonds, what's on the oxygens on the outside of diamond?
hydrogen and oxygen.
They're oxidized or
Yeah, they're
reduced.
all oxidized. Yeah, or graphitized as well. So often you can get, particularly over time, they get dull diamonds, and that's because they're actually converting to graphite at their surface.
Ah,
Yeah, so you have to polish them, and that wipes off the graphite, which is soft. And
so the diamonds are not forever. You're
Absolutely
wearing away a
not.
layer every time.
Well, yeah, and I mean, over time they will go to the thermodynamic minimum, which is graphite.
But it's geological time, usually it's not.
Oh yeah, it's actually longer than the age of the universe to turn
No.
diamond into graphite. It's
Longer than the
at
universe.
room temperature at least, and atmospheric pressure. So it's not happening anytime soon.
It's nifty.
So anyway, but it's quite a nice.
There's even a hydrogen molecule here. No, not a hydrogen. must be
No, that's the
oxygen.
controller.
I think it looks like 2 double bond.
Here we go. Yeah, this is what happens when you get a physicist to do something.
Ah. So that's your other controller.
Yeah, so your hands are bonds.
Oh, okay.
So it's a bit of a joke that you're
Yes.
kind of,
It's a wrong colour for oxygen. It's the
Yep, it's
chemists will
wrong.
see that as hydrogen,
Yep.
but the double bond
Yep.
says it's not hydrogen.
I know, I said this term. But, anyway, it's part of the joke, I think. Is that it's clear physicists have made it.
Yeah.
It's wrong in lots of ways.
But that's okay.
Anyway, I might pull you out tomorrow because if you are in too long, you will feel ill. It's just an inevitability. So,
And I'm not as good. So seems to be able to handle the inside VR much
Yeah.
longer than I can.
so I'll show you a video of the other one. It's basically so that it's a bit quicker. So the other one is this one here, which is inside here. So that literally just is
So these are like carbon nanotubes or
Well,
graphene
we
type
call
things.
them disordered carbons. They're like when all those nanoforms fuse together and form a solid. And that's actually what charcoal is really. It's a mixture of fullerene structures, tube structures, graphitic layered structures, kind of all together. So it's a very complicated structure. It's this actually the VR has been very helpful for us understanding it. It's very hard to, and we're even like only a couple of weeks ago we discovered a new type of defect which I didn't see at all, which is what's called a wedge disclination, where the sheets kind of come together and then they fold apart. And I saw it in the VR, so it was yeah, it was good to see that, you know, for the.
So you basically you can, it's a bit like the geologists and surveyors used to have the standard maps and just surveying, looking at the same data all the time to dig in.
And you have to see it in different ways. So we look in the computer, and then we have like you might go to the Hive, and we've got big 3D displays. So this is we can see inside. This is quite good for seeing inside. And then we also do 3D.
Callum was a student.
Yeah, Callum was the student that did the work. He's now doing a PhD with us, which is lovely. And then we also do 3D prints of the structures, which help as well. And this here is actually using something called Nano. This Nano, which is a protein software.
Okay.
And so if you put all of the atoms in as hydrogens, then they don't try to do bombs everywhere, and then you can actually see structures. So,
So
this
if you
is
put it in something else, they automatically connect.
This is a commercial software for proteins, and it's grab based. So you grab and you move it around, and then as you grab and pull, they get bigger. So it's quite nice software actually.
What's the software's name?
Nano. So
Nano.
let me just zoom in. There you are. Yeah. So that's basically that's my demo. So I'll give you the batteries back, and if you've got time to show me what you've got as well.
Yeah.
Sop is a primary school teacher with a biology education background.
Oh well, you like Nano. You got lots of secondary structure, protein secondary structure.
In Nano map, I can install different kind of files.
Yeah. So you can load up PDBs from the protein database files. You can load up XYZs from the. It's limited in terms of the processing power of your VR, so that's a bit of a problem, but it's not too bad.
And your VR is what? It's Quest
3, yeah.
But 128 to.
Oh, I think I bought the lowest one. I'm never going to get up to 128 with the games that I'm running. I mean, these games are sort of like not even a gigabyte.
Yeah, okay.
They're not big at all. I think unless you're gaming and you're loading up enormous games, it would be hard to get going up to there.
So that 128 includes the storage of, technically you could do, if you got a gigabyte games, you have 128 of them you can put on.
Yeah, and I don't think, and to be honest, if I needed to, I've never had any trouble with the storage. But I think if you had a complex game and with lots and lots of,
No, I don't plan to use it for games.
Yeah, if you're ever doing it for education, you really don't need that. And if I need a game, I'll download it. That's
I've got a couple of situations that I might get away with not even using that, but some crystal structures where we're looking at the unit cell, and where there are many molecules in the unit cell, and we're able to navigate around to see it from different directions.
I mean, VMD is quite good. If you one thing that I think people don't know about is the navigator mode. So if you go into,
which one's this?
In VMD, which is Visual Molecular Dynamics, they've got a mode called Camera Navigator mode, and if you go into, say, CPK, or maybe I'll go into Van der Waals spheres, yeah, and then if I go and zoom into the structure like this, if I go to this flying camera mode, I can actually fly through it. So if I press the, if I go F, I will start to, that's not, oh maybe I have to go 1 first. Yeah, P, that's right. Oh, there we go. Okay, so now I'm moving around, and now if I click, I go forward. So this means I can sort of zoom around. It's not really ideal. This is the closest I got to something that's sort of similar to what you have. It's not, it's pretty bad. But this is what I used to do. I used to just zoom around the structure like this and get lost. Oh, there we go, come out. At least this doesn't feel too ill. If you've got the 3D on it as well, it helps. But I do quite a lot of, I'll record this, right? If I go pause, yeah. I'll record this and then I'll play it as a video with Anaglyph, and then I can show it in a lecture. So that can be that can be a way of actually doing it, you know, having it in a lecture. Actually, did I put it into this? No, I didn't. It doesn't make sense to. Maybe it's, where did I? Physics of a candle, that's right.
Oh, and you also did chemistry of the candle.
Yeah, I did a chemistry of a candle. Depends on, like in this case, I was talking about ferromagnetic states and like spin states and so it was a slightly different talk. But yeah, it's sort of, I'm a weird, I'm on the verge between the two, and I'm not quite sure what I am day to day.
That's okay. I've been like that for a long time.
Yeah, is that all good?
Yeah, it's mirroring.
All right, okay.
I made an app. This is the app I made with some company. So,
cool.
I wanna make real version of Magic School Bus. Do you know
yes,
Magic School Bus?
I know the Magic School Bus. Yeah, that inspired a lot of this too. Yeah.
And I was inspired too.
The new Magic School Bus is horrible. Do not look at the new. There's a new Netflix Magic School Bus. Don't. It'll ruin your, your childhood. It's the old Magic School Bus where it's at.
And I want to show students the perspective of food.
Yeah.
Food, and they are swallowed. And go.
Yes.
And I can see inside of the organs, digestive organs, and outside of the organs. Okay, you can.
All right. Oh wow, that's great. And the controllers.
Okay. You don't.
All right, and I go digestive process.
Yeah, you can outside view and inside view.
Oh.
Yeah, outside view. Okay.
Oh.
You are swallowed.
Oh no! And this is outside, but
you can go outside.
Oh, but can I go inside?
No, you are inside.
You are inside already.
I'm inside. Okay. I go outside.
Outside look.
Oh.
You can see outside look. So, okay. Okay. Inside.
Oh wow, that's so cool.
I want to show inside and outside.
Oh. I love the music too. So how do I go to
You can go inside and next test.
Next part.
Yeah.
Oh my gosh, it's a roller coaster.
Yeah, it's like a roller coaster.
Oh my gosh, this is so cool.
Yeah.
And I go inside and I go, oh wow, it's that little nugget of food is shooting down like a Oh, the kids will love this. Oh, the adults love it too, I think. All right, next part. Oh yeah, this might involve a bit of vomit.
You can
That's all right,
close your eyes.
my eyes.
Oh yeah, you should close your eyes because small intestine is longer than your thought.
Yeah.
Okay. Yeah.
Oh wow, look at that.
Yeah.
You know what's interesting is that in games you don't move through them. I've discovered this. So what they now do in games is you jump to the next thing. So you point at the ground and then you click. You kind of jump, and that apparently means that there's no vomit. So in most of the new games, I had a student work out what is the best way to move without vomiting. And they basically point at the ground and click, and then they jump there. And teleportation doesn't lead to vomiting.
Yeah.
It's apparently the best way. Like most of the best VR games are now going to teleportation instead of. Oh, that's wonderful.
Thank you.
I did biology for a bit, and I did a biotech project, and I did not keep anything alive, so it's not a good job for me. Wow, I love the animation. This would have been quite a bit of work to do. And to make it all kind of do that. And the squidging noise is critical.
I have
Oh, there we go.
You should close your eyes.
Yeah. This is a journey that you don't want to. Oh, okay. I do actually have some biology students coming at 4, so they might actually like this. They're biochemists from UWA who wanted to do. I said, but we could. They might actually have some fun with this. All right. So tell me when it's stopped. This is quite the journey.
Yeah, quite.
This is the roller coaster effect that I am not good at.
Yeah.
Press the outside button and you can escape.
Yeah. All right. Oh, that's a good idea. Wow, that's very long.
Yeah. Students also says they didn't know that small intestine is so long.
Yeah. No, it's definitely not. Oh, there we go.
It's large intestine.
That's short but wide.
Oh, and kids love talking about poop too, so that's great.
That's all.
Wow.
You can, after all the journey, you can go some part that you want.
I see. You can go wherever you want.
Yeah. Okay.
And that's the expedition where you journey through it.
Yeah.
Oh, that's wonderful.
Okay. I'll show another one.
Yeah. Oh, thank you very much. That was So how do you make it? Oh, this is the casting. So you set that up on your phone, the casting, or does the casting go direct to the
casting directly, mirroring by this site. So I can show and when I log in, same ID.
Because I struggle. Does that mean that the Wi-Fi here has to be
Wi-Fi
here?
same
you have
Wi-Fi.
So, and you have this as this is producing a Wi-Fi connection. This is a router, and is this connected to this Wi-Fi?
Yeah.
Oh, okay. Yeah.
Same Wi-Fi to my phone.
They're both hotspot to the phone.
So you hotspot to the phone.
phone,
Okay, because I know that I've got my laptop's got Wi-Fi 5, so I can actually connect to my laptop. So that connects direct to my laptop, so I can do direct casting. But that's good actually. It's good to know I can do. That's another way to do it, I suppose.
You can also mirroring by casting. Google Chromecast. You can.
That's a good idea.
It's you should connect Wi-Fi with Google Home app. So you can and same Wi-Fi network it works. Casting. And when you can. Yeah,
I know. I've done the casting. Yeah, and then you press casting.
In camera, there's a mirroring option.
Yeah.
So you can mirror and while mirroring, I can push that button, but you can mirror. And,
Right.
and
then it goes to, and then you have to just go to oculus.com/casting.
Yeah.
Oh, that's good. I'll write that down. I haven't managed to get casting working very well. I usually just do. VR like this here, which is I record this with anaglyph. You want those?
I can reach the bottom.
Yeah. These are my double-sided Velcro.
Oh, okay.
So they can stick together. How cool is that?
Oh, that's cool.
So you can make a layer and then you stack them into HCP or into BCC.
Have you seen our magnetic water molecules?
Yes, yeah, they're really
Magnetic.
cool. Snapples, right? There's also ones you can get from, the magnetic ones. I think you can buy them. I tried to get Ming to buy some.
We've got some in the VR lab.
Oh, good. Okay.
We bought 4 or 5 packets, and so it's really good for investigating hydrogen bonding and getting an idea that you need energy to break bonds and things like this.
Oh yes, I've played with this. This is very good. Yeah, the sketching. Yeah.
Do you know gravity sketches?
Yes. The other one, if you really like, if you like things getting small as well, there's actually a game that came out on when you shrink down to the atom scale. There's a game that you can actually play. What's it called? I have it on my VR. You might like this because it's a game that someone made, and you have to shrink down, and then you have to solve problems. Then you have to shrink up, and you have to solve problems where someone's got a shrink ray, and you've got to sort of find the objects at different scales, and then you have to shrink them to the right scale, and there's 3 different scales, I think. So, but one's the atomic scale, one's the biology scale, and that game is called. It's called. What's it called? It's a science community. It's like a education game.
There was a science fiction show many years ago, and they're saying we've got this photo. We've got the photographic data of the planet, but we don't know what the scale is.
Right.
And someone says, surely that doesn't matter. You can tell. I can tell the difference between a woman, whether it's whatever scale. And then they showed these images, and it was a photo of a woman, but at almost biological scale of the crease of the leg here. And then it moved out. And then the first one he said, I can see these forms. He's thinking of it. A surface of a planet.
Oh, right.
And then it moved out, and then when it goes full scale, and it says,
that's very funny.
So,
well, that's very similar to the powers of 10, right? The classic powers of 10.
It has a little bit more impact than just telling them that scale's important. Most people recognise a woman when it's scaled down to just a small 1 square millimetre or micrometre.
Let me see if I can find. Oh, actually, maybe I've got it in my Oculus store. I'm not very good at. Oh, Oculus. Because this game, I played it myself, and it's really good for. I think it would be really good for students actually, because they're quite. This is annoying. Oh, no, I have to go to this stupid. This is to annoy me. I have to flip over to my other one.
Login is.
Login code.
Fortunately, the computers remember some of these things.
No, I don't want to do that.
Did not connect it to
student. This is the student who's done it.
Okay. Well, you can use the battery.
That's right. I should be able to find this game. It was done by a YouTube channel called get it. That's surely close enough. If I go to Google, there's a YouTube channel that animates science. That I won't be able to find now. Yeah, okay. Education, scale, atom, shrinking.
You gotta write the full abstract before it finds it.
Yeah. Oh, scale of universe. It's not very good. No, it is. Here it is. Out of scale.
Oh, out of scale. Oh, yeah.
And this is really fun, and it's beautifully animated, and yeah, it's really, really good. So you can change to the size of a, you know. This is one of my favorite. It just came out, and it's shrinkagen, and it'd be great for kids. I think it'd be wonderful for kids.
We can fix this together before someone notices.
Yeah. Yeah. Changing scale is very.
But what they do is to be honest, I think it's good to, jump around scales in sequentially. It's very hard to zoom. Zooming people don't like. So jumping scales is slightly easier, I think, for people.
So, you know, we often talk about the idea of zooming in, but you're saying that if you're zooming in, then they're more likely to get sick.
Yeah, and we're now doing, actually I have a report from a student where he summarized all the different types of motion that you can do in VR games, because he's a VR gamer, the guy that wrote the game, like that's his pastime. It's great, you know. I like to get students to do their hobby project because it means that they, you know, like all the 3D prints were done by a guy who likes to do Warhammer. So he prints small models of like warriors and, you know.
Oh yes.
What was I looking for? Forgotten. Yes. No, I've lost it.
Oh.
Yeah.
You made at the couple of years ago when we had the virtual, the advanced science exhibition, you're showing off what you're doing with the carbon dam. I think you made the comment about eye problems, eye damage.
Oh yes. So one of my students was doing the game development, and then at night he was playing VR games till late, and he needed glasses. So he was straining his eyes because they were not, you know, it's like looking at this, and if you have bad eyesight and you're long-sighted, you're straining your eyes. So and then he got headaches, and he couldn't do the VR for more than an hour a day. And he told me after a week of this happening, I said, "What are you doing? Stop the VR entirely." You know, he felt like really bad, and he went to an optometrist, got glasses, and he had exercises to do. And so we stopped all VR for a whole month until the optometrist said that they could go back and do more. And even then, I was very cautious of them doing too much on the VR, but just doing most of it on the computer, and then not. Actually, I think he did a literature review then, because I said, let's not even. So he just did a literature review, but that was really, potentially problematic because of his eyesight. So what I would say is, if someone is going to develop VR, they should get a test done first. An eye test.
I'm short-sighted, so I wear these to see. I can't read with my glasses on, but my right eye is pretty good. My left eye is better. My right eye I can see the prints on my fingers. My left eye can't, but my left eye sees you better than my right eye.
So that actually would be the case where you should keep your glasses on during VR because you'll be straining your eyes.
But with this, I can't see anything. I can't read unless I've got it over here.
But the optics in this should put it quite far away from you. So the optics in here should give you an equivalent image at a long distance.
Okay, so in that case, I thought that because I was focusing here, I'm better off without my glasses.
No, so the glasses, the actual optics are designed to make an image that's very close appear at infinity.
Okay.
So it's supposed to, so it should reposition. I don't know what the distance is, but the focal length of the lenses is such that the image should be placed quite far away. So it's like if you have a magnifying glass, right? It makes it seem like the thing is very far away, and that helps someone like you know. So glasses are really good, particularly if you have different strength in each eye, because this corrects for that. Because if you put it on, it's equal each side, so it'll strain your eyes.
So when I was doing this, I was better off
with the glasses on.
Okay.
Always better with glasses on, and that he had to do exercises where he focused far away and close. Like it was quite a big deal. I felt very bad. I should have asked. I guess I asked. He's like, yeah, it's going slowly recently this week, you know, in the week, and I was like, never keep going. If you've got health issues, you need to stop. But immediately and have a
he may not have clicked that was the issue.
Yeah. Well, I didn't know whether it was something to do with the VR itself, but then I realised it was because he has never worn glasses, so he'd never had his eyes checked. So he really should have. So in hindsight, now when I do VR projects with students, if they've got glasses, it's fine. But if they don't have glasses, I recommend that they get an eye test. Otherwise,
because I remember when I first got my glasses, I was, wow, those lights are actually crisp. I can see the leaves on the tree. And for a long time, I didn't realise that was so bad.
It is. And the other, I wanted to show you one last thing, which is I did an outreach thing for what was it? It was outreach in a prison, and we took the VR headset into a prison.
Prison?
Yes. Which was interesting. And it was called Think Like a Scientist. Yep. So we went into Geraldton prison, and we went into where else did we go? I think we went into the women prison down the road, and then I might be running out of memory. That should be okay. And yeah, figures. There's for that other one. No, we don't actually need that offline. Online only. Yep. So and I did like a whole thing on renewable energy, and so we bought 2 VR headsets into there, which is apparently the first time in WA they've done VR in the prisons, I think. And so we did. I had this sort of. I started off by asking them like, what's something you've made, something that you like to make, you know, and then we and then I showed them this picture here from an Aboriginal artist from Alice Springs, and this piece of art is about the cattle ranches, and these are all the cattle, and then this was, and the sand is kind of what zoomed in, and a scientist was inspired. There was like an art cultural exchange between scientists and Microscopy Australia, where they imaged the sand from this region. So that is the atomic scale image of the sand from Alice Springs, which is really nice. So, and it's kind of the similarity of the dots from very high up, seeing the cattle, and then very close up, the dots are also there. So the idea that down at the very smallest scale, everything is dot-wise, whereas in Aboriginal thought, often the dots are a map from above. So they're usually topographical, or they're usually quite high up. So this is like zooming in. So scale is already part of that indigenous knowledge. So I was kind of talking about that, and then I showed them the Mel VR, but just as a video, and then we went through the activity with the ping pong balls, which is one activity you can bring into a prison, which was a challenge for me to find an activity that would pass the rules, and I don't know how I got the VR in there, but we got the VR in there too, and we talked about how this is inside of the battery, so that was quite fun, and I talked about the battery and some of the work that we're doing on batteries as well. Yes, yeah. So the graphite is actually in the batteries, and we studied the defects inside the batteries, which is the screws, and talked about how when you and then I did this video where you zoom around using anaglyph. So and then you can do the other side. Oh, I don't think I did the other side. Just did one side. So the graphite layers, and then. So that was quite fun, yeah, and they really enjoyed this activity of making the atoms. And, yeah, so it's quite, the fact that you can bring the VR into they wouldn't even let me take a laptop, but they let me take a VR headset. They said the laptop can connect to the internet. And I was like, yes, the laptop can.
So they were concerned that if the kids were playing,
they could get onto the internet and
and communicate with the outside,
yeah,
and plan their escape.
But I kind of said to them, the VR also connects to the internet, but it would be quite hard to load up something and then have to type stuff. Like it would be much harder to do stuff.
Yeah, you can't send the message.
It would be, they could, but it would be hard, and I would know what they're doing pretty quick. Because I know what activity they're doing. So, but I had one student, one woman saying that she was like, this was like the closest feeling to being out of the prison, because it was like a completely different place. And a lot of the people in Geraldton, a lot of the Aboriginal prisoners wanted to go on country with them. So they said, can you do something where you actually put me back in the place where I am from, so I can be out on the land, which is like, oh, that's pretty tough, yeah.
But you've got one way.
You can,
Google, link to Google Maps.
Yeah, Google Maps, yeah, Wander.
Yeah.
The thing is, my father is like techie, and my brother's techie, and they both bought VR headsets well before I did, and they have all the games. And they keep telling me I'm backwards, I'm a Luddite, that I'm so slow, because they're much faster, which is funny, because this is so they actually, my parents actually together they have two, and they go wandering together down the streets and stuff. So it's quite funny actually.
And so when they wander with that app, they can see each other.
Yes, I think. I'm not actually sure. I've never done that.
So each other where they are.
Oh, you can? Okay, in Wander. I've never had to connect it with Wander, so anyway, I think one of my friends is probably so that's quite good. And I've done the sketching as well with Gravity Sketch. I've actually imported STL files, which are mesh files in there, data, and then I have done data from scanning tunneling microscopy, and then I've annotated and I've pulled in molecules, which is also STLs, and so then you can actually get the scale right, and you can actually see which patterns on the STM match the different molecules. So I've actually done 3D data sort of together.
Where did you download the STL file?
I made it, yeah.
You made it?
Yeah, but it's not too hard. Like in STL is just a series of triangles. So if you go to render STL, then you can render whatever's in VMD as an STL file, and then you can upload it to anything you want.
I'm finding some kind of way to download from some molecular structure in from homepage, in some kind of homepage, and yesterday so
Yeah, so the thing you'll need is VMD.
and sorry.
You can do OBGs as well, but OBGs are a bit nasty. But
Yeah,
OBGs have the
FBA
color. Yeah, OBGs have the color. So
FBX has a color too.
Yeah.
So
STLs are very good
and
for color.
I will show you. I will show you. And nowadays I can make
Did
modeling.
you say you had biology students coming